Hello students, this is the continuation of exercise 1.3 of class 9 mathematics. We have done up to question number 4 in the previous class. Now I am continuing with question number 5. Question number 5 is, what can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 upon 70. Perform the division to check your answer. I repeat the question. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of 1 upon 70? Means, in the decimal form of 1 upon 70, there are some repeating digits. That is meaning of this question. And in that repeating digits, what can be the maximum number of digits in that repeating block of number? There is a rule for it. If the decimal expansion of a given rational number is non-terminating recurring, then the maximum number of digits in that repeating block will be 1 less than the denominator. Here the denominator is 70. So the maximum number of digits that can be in the repeating block of the decimal form of 1 upon 17 will be 60. 1 6. It is the rule. It will be always 1 less than the denominator. Minimum number of digits can be anything. Minimum can be anything. 1, 2, 3, 4, anything. But it will never exceed 60 because the denominator is 70. Today, you do 1 upon 70. All of you divide 1 by 70. And see what is the answer. See what is the answer. Now, when will you get the repetition? Whenever you get the remainder again 1. When you do the division, if at any place, if you get the same 1 again as the remainder, from there all the answer will be repeating. So you continue the division of 1 divided by 17 and see after how many places you are getting the remainder 1 again. You can see that after 16 places, 16 digits, you will again get the same remainder 1. So, all of you do and find out the answer of 1 upon 17. Then count the number of digits that are getting repeated. Means, whenever you get the remainder 1 again, from there all the answer will be repeated. Perform the actual division and see after how many digits it repeats. The answer is 60. 1 less than denominator. Next question. Look at the several examples of rational numbers in the form p upon q, where p and q are integers with no common factors other than 1 and having terminating decimal. I repeat the question. Take some examples of p upon q where p and q have no common factor between them, or they are also called coprimes. If two numbers have no common factor between them, they are also called coprime numbers. So in a rational number p upon q, take a rational number where p and q are coprimes, where p and q have no common factor. And it must be a terminating decimal also. Rational numbers can be of two types, terminating or non-terminating recurring. Take an example of a rational number p upon q having two conditions. Number 1, p and q should not have any common factor. Means numerator and denominator should not have any common factor. In other words, we can say it must be in the simplest form. Second, its decimal expansion must be terminating. Then the question, can you guess what property Q must satisfy? In such a rational number of P upon Q, what property the denominator Q must have? Question number 6. So take an example of a rational number P upon Q, where P and Q have no common factor and its decimal value must be terminating. Then its denominator Q has a particular property, and the property is that the prime factors of Q will be always 2 or 5 or both 2 and 5. This is the property. If a rational number P upon Q, where P and Q have no common factor and its decimal representation is terminating, then its denominator Q will have prime factors in the form of 2's. Not only 1, 2, 2's or 5's or both 2's and 5's. Means any number of 2's or any number of 5's or both any number of 2's and any number of 5. Means this Q will never have a prime factor other than 2 and 5. You will never get its common prime factor other than 2 or 5. This is a rule. If a rational number P upon Q is terminating decimal, provided P and Q have no common factor, then its denominator will always have its prime factors as 2's or 5's or both 2's and 5's. This property will be repeated again in your class 10th mathematics under a special name also. So this is just an information. You will study it in class 10th as a special rule. So this is the answer of question number 6. Now question number 7. Write three numbers whose decimal expansion are non-terminating, non-recurring. Write three numbers whose decimal expansions are non-terminating, non-recurring. So, we know that non-terminating, non-recurring decimal numbers are irrational numbers. So, you can write three such numbers which are irrational and whose decimal expansion is non-terminating, non-recurring. So the numbers can be root 2, root 3, root 5. Or in decimal form we can write, I am giving you the answer in both the form. These are the numbers whose decimal expansion will be non-terminating, non-recurring because they are irrational. Now I am writing exactly that non-terminating, non-recurring forms. In decimal form also I am giving you the answer of this question. Say for example 0.123 1123 11123 dash 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 5.43 433 4333 dash dash. Now 7.245 2445 2445 dash dash dash. Look at these decimal numbers. These decimal numbers are non-terminating. You can see this dash 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 at the end. That means it is non-terminating. Now they are non-recurring also. See, these digits are not repeating in any particular order. It is 1, 2, 3. then only 1 is repeating, doubled, not 2 and 3. Here 1 is triple. So we cannot express these numbers with a bar sign. I have already told you this in my previous class. So these are 3 such decimal numbers which are non-terminating, non-recurring. These are 3 numbers whose decimal expansion will be something like this: non-terminating, non-recurring decimal. So that is the answer of question number 7. Now question number 8. The question is, find 3 different irrational numbers. Find 3 different irrational numbers between the rational numbers 5 upon 7 and 9 upon 11. Find 3 different irrational numbers between these 2 numbers. What type of numbers are these 2? These are rational numbers. They are in the form of P upon Q. So this time you are given 2 rational numbers and you are asked to write 3 irrational numbers between them. Listen carefully. So far we have not done this type of question. How to find irrational numbers between 2 given rational numbers? The method is, first of all, we have to change both these given rational numbers into decimal form. 5 upon 7. Do the division 5 upon 7. 50, 7, 49, 10, 1. Leave the remaining digits. We may require the answer only up to 2 decimal places. So 5 upon 7 is 0.71 approximately. Whether it is terminating, non-terminating, no problem. Similarly, find the value of 9 upon 11. 0.821. So it is approximately 0.81. So see, the decimal value of the given numbers are 0.71 and 0.81. Now you have to write 3 irrational numbers between 0.71 and 0.81 which are non-terminating, non-recurring, because every non-terminating, non-recurring decimal numbers are irrational numbers. So if you write 3 non-terminating, non-recurring decimal between 0.71 and 0.81, that will be the answer. So then this number is 0.71. So you must start from minimum 0.72 and you must stop before 0.81, means 0.80. So note down this. The first number must be greater than this and the last number must be less than this. So I am starting with 0.72. So we can write the required numbers are. I am starting with 0.72. 0.72, 722, 7222 dash dash dash. I am starting the next number with 0.73, 733, 7333 dash dash dash. Another one we can start with 74, 744, 7444 dash dash. In this way, you can write infinite numbers, decimal numbers which are non-terminating but non-recurring. I have repeated only the first digit. No, second digit. 72, 722, 722 dash dash. Same way you can repeat 7 also. 72, 772, 7772, another pattern. In this way you can make plenty of patterns. The only thing is that this number should not be in the form of repeating. It appears to be repeating, but it is not repeating. 72. If we have to represent this number with a bar sign, then the digits under the bar must be repeating. You cannot put 72 bar. 72 bar means 727272. It is not 727272. Only 2 is repeating. So we cannot represent these numbers under the bar sign. So these are non-terminating, non-recurring decimal. So these are the 3 non-terminating, non-recurring decimal lying between 5 upon 7 and 9 upon 11. Next question. Question number 9. Question number 9 is the last question of this exercise. Question number 9. Classify the following numbers as rational or irrational. First one, under root 23. Second one, under root 225. Okay, let us explain one by one. Under root 23. All of you know that under root 23 is an irrational number, because under root 23 is not a perfect square number. 23 is not a perfect square number. Leaving the perfect square numbers, all other numbers under root are irrational. Under root 25 is rational. Under root 16 is rational. So, more than 16, that is 17 to 24, all are irrational. So, under root 23 is irrational. Now, what about under root 225? We know that 225 is a perfect square number. 225 is the square of 15. So, under root 225 is 15 and 15 is rational. So, under root 225 is rational. Now, third part, 0.3796. You can very well see that 0.3796 is a terminating decimal. See, there is no dash dash at the end of this number. So, it is a decimal number which got terminated. Every terminating decimal is rational. So, this is also rational. Fourth, 7.478 dash dash dash. You can very well see here 7.478478 dash dash. This dash dash indicate that it is not terminating. But if you look at this digit, you can see that 478 dash dash. That means 478. These 3 digits are repeating. So we can also write it as, this number can also be written as 7.478 bar. So it is a non-terminating recurring decimal. It is a non-terminating recurring decimal. Every non-terminating recurring decimal is rational. So this is also rational. Now the last question, 1.10 100 1000 1 4 times 0 1 dash dash. You can very well see in this question, first is 1 0, then 1 00, 1 000, 1 4 times 0 dash dash. Already we have discussed this type of question. This part of the decimal is non-terminating, non-recurring. This is a non-terminating, non-recurring decimal. Every non-terminating, non-recurring decimal is irrational. So this is irrational. So in this question, only the first one and the last one are irrational. These three are rational. So it is more about the properties of rational and irrational numbers. I conclude, rational numbers are of two types of decimal. All the terminating decimals are rational. All the non-terminating recurring decimals are also rational. But all the non-terminating, non-recurring decimals are irrational. That's all for today. I hope all of you understood. Please practice.